Okay. Okay, the transcription started. So in Bash, you can define variable, and you can work a variable of, you can define string, sorry, and you can work with the string. So let me show you some example on how to work with string. Let's say that I define a string A, like Jacksonville. So of course I can echo the string S, it will show me Jacksonville. If I want the length of the string, the syntax will be dollar, curly bracket, number, and the name of the variable. So you see Jacksonville, for example, have 12 characters. Let me change S. Let me put, for example, yes. And ask for the length. It's a 3, no? So it does work. Let me go back to Jacksonville. You can also ask a substring. So for example, if I want Jack, I can say, for example, echo from S, the substring that starts in index 0. The first character is index 0. If I want Jack, I need 4 characters. So from index 0, a total of 4. From character 0, a total of 4. We have Jack. If I just want the J, I will say a total of 1. If I just want the A, I will say starting in character 1, a total of 1 character. If I want the K is index 3. If I want the last character, I can say 0, it has 12 characters, so it will be character 10, no? So, no, so it's character 11. Character 11, a total of 1. So you can ask a substring, no? If you want son from Jacksonville, son will be, let's see, 0, 1, 2, 3, 4. Index 4, a total of 3. So let's do that. Index 4, a total of 3, it gives me son. Okay, this is the way to work with string. Now we can define also array. Let me define an array. To define an array, you put the elements between parentheses. For example, this is an array. It have, let's put a little more elements. 1, 2, 3, 4, 5, 6. It has 6 elements. So you put the element and you separate the element with a space. So if I want the length of if I want to echo the array, it's a little strange, the syntaxes. So you will put this. This will show you the element of all the elements of the array. So the arrobas mean all. So A arrobas, square bracket arrobas mean all the elements. Now, if I want a specific index, for example, the 9 is index 0, is the first element. I can just say I want index 0. Or I want index 1, which will be 7. Or I want index 2, which will be 90. And if you want the length of the array, you have to say this. So numeral normally is the length. The length of an array that contains all the elements. So it say there are 6 elements in this array, as you can see, no? I can create an empty array. If I say what is the length of the empty array, it will tell me 0. Okay, so that was just a review on how to manipulate string and array, because we are going to need them to finish the exercise that we were doing. So let me go back to this exercise. So I was showing you how a Linux machine is going to store the hashed password. When you type a password, the password is stored in a database. This database is the file /etc/shadows. And there are many ways to represent it. And one of the algorithms use SHA-512 is the one that we are seeing in this moment. So we say that we will have the magic number at the beginning, which is $6. Then we have the salt, and the salt have to be between 8 and 16 character, and it can be any character in this set. It can be a dot, it can be a /, it can be any digit, any uppercase letter or any lowercase letter. And we have the encrypted field, which will be 86 byte long all the time. So we already saw how to compute. There are three parts when we do that. There are initialization part, there is a loop part, and a finalization part. Last time we did the initialization part and it did work well. So let me just go over it. So to do the initialization part, we need to compute three parts, part 01, part 02, and part 03. So part 01 is the concatenation of the password and the salt. So for example, in the exercise, we were trying to encrypt Eric with this salt. So the concatenation of Eric as hexadecimal string and the salt as a hexadecimal string will give us that. And this is called part 1. Then to get part 2, what we are going to do is that we are going to concatenate the password. Here we can see it. The password, the salt, and the password, and compute the SHA-512 on it. No? So the password is Eric, the salt is this string that I decided to use. The password is Eric, and when you take the SHA-512, you get this result. No? So, sorry, first to compute part 2, we need to compute alternate, so this is alternate. So part 2 is just the beginning of alternate, is have to be the same length of the password. So for example, Eric is 4 bytes long, so we are going to take the first 4 bytes of alternate to get part 2. Then we compute part 3. So to compute part 3, we take the length of the password and we pass the length from right to left. So for every 0 that we find, we are going to concatenate to an empty string. We are going to concatenate password. So we start with an empty string. So for example, for this 0, we concatenate password. For this 0, the second 0, we concatenate password. And every time that we have 1, we concatenate alternate. So in this case, it's password, password, alternate, and then we have part 3, no? With the 3 parts, we can compute the initial value. So to compute the initial value, we concatenate the first part, the second part, and the third part, and we compute the SHA-512. This will be the initial value. With this initial value, we can go to the second part. So we just finish the initial part, and we do have a program that do the initial part. If you remember, let me show you. We did a code. Let me edit the code. It was hashed password. It is there. And we just finished the initial part. So as you can see here, for example, here, I'm parsing the password and let me see. Oh, we still have to compute more things. Sorry. Out of the initial value, we need to compute the p bytes and the s bytes. So let's see how we compute the p bytes. The p bytes are obtaining from the password. So The p byte will have the same length as the password. So the password is Eric, have 4 characters. So the p byte have to have 4 characters. So how we obtain the p byte? We take the password and we concatenate the password to itself 4 times. Why 4 times? Because the password is length 4. So we will do that, the number of the length of the password. So after that, we compute the SHA-512, and over the SHA-512, we will take the first 4 bytes because the password is 4 bytes long. And the first 4 bytes will give us the p byte. We also need the s byte. So to compute the s byte, it's a little more difficult. We need to take the first byte of the initial value that we just computed before. So this first byte is 26 in the hexadecimal. 26 in hexadecimal is 38 in decimal. So the number of times that we are going to concatenate the salt will be 16 plus 38. And 16 plus 38 is 54. So we are going to concatenate the salt with itself 54 times. And then we are going to compute the SHA-512 of this result. And since the s byte have to be the same length of the salt, and my salt is 16 bytes, I will take out of this string, I will take the first 16 bytes. So we obtain this. Okay, so now we came to the iteration. We stopped there last time. So this is the second part, no? Because we just finished with the initialization part. So in the iteration part, we have to do it 5,000 times, from 0 to 4,999 times. And each time we need to update the intermediate value. So the initial intermediate value will be the initial value that we computed here. So let me show you. Here we computed the initial value. So we are going to use this initial value to initiate intermediate. And for each time that we will go inside the loop, we will have to update intermediate according to this rule. So there are 6 rules according to the index I. So it's, if the first one say if I is even, I have to take into account intermediate and concatenate it. Then if I is odd, I have to concatenate also the p byte. Then if I is not a multiple of 3, I have to concatenate the s byte. Then if I is not a multiple of 7, I have to concatenate the p byte. Then if I is even, I have to concatenate the p byte. And if I is odd, I have to concatenate intermediate. So here we have an example of each iteration. So I was explaining last time what will happen if the iteration is 0, if 1, we saw that. So I'm going to just keep this information, and continue to modify my program according to those rules. So let me put the rule here. Hopefully you can have both the virtual machine and the rule and work on both. So let me try that. Okay, so I'm going to show first the string, like here. I want to show something like, that's a iteration 0, I have intermediate and the p byte. Iteration 1, I have the p byte, the s byte, the p byte, and intermediate. To show that I know how to program those rules that are here. So let's start. Let's do a 4. So 4, we have to do it 5,000 times. So I'm going to use the for that use the syntax of C. I'm going to start in 0. I is going to be less than 5,000, which means that I will stop in 4,999, I plus plus. So let me put the do and done here. So I'm just going to program what we have here. So look at the first one. If I is even, how can I know if I is even? What should I write here? How can I put a condition I is even here? Let's put, for example, because I want to show iteration and the number of iteration, let's put here an echo, and we are going to put maybe a printf is better. Yeah, printf is better. Printf, we are going to show iteration. The number of the iteration, I want to show it as an hexadecimal number of a 4-digit. Okay, so I'm going to show the iteration. How do I say if I is even? Because this is the first of the 6 conditions. What can I write here to say if I is even? So an even number, if you divide a number by 2 and the modulus is 0, it's an even number, no? So we can say if I modulus 2 is equal to 0, this is an even number. Then I want to show what? I want to take into account intermediate. So here I'm going to say echo, don't go to the next line, intermediate. And that's it. So phi. Okay, I have the first condition of the 6. Now let me copy this 3 line. And we are just going to modify it. Okay, let's go with the second condition. So the second condition, if I is odd. How can I test if I is odd? So if when you compute I modulus 2, the result is 1. So this will be odd. So if I is odd, I have to take into account the p byte. So let me write here p bytes. Now we have another condition. If I is not a multiple of 3. So let me copy this 3 line. How can I know that I is not a multiple of 3? This will be the condition, no? If I compute the modulus of I with 3, the result is different of 0. So it's not divisible by 3. In this case, I have to take into account, this is the third condition, I have to take into account the S byte. So let me write, show the S byte. Okay, we come to the fourth. Let me copy this 3 line and let's do the fourth solution. So if I is not a multiple of 7, that will be I is not a multiple of 7. So if I is not a multiple of 7, I have to take into account the p byte. So let me put here the p byte. Then we have if I is even. This is easy. So to know if I is even, I divide it by 2. And if the modulus is 0, it's even. So if it's even, I need the p byte. I take into account the p byte. So let me just write here the p byte. And finally, the last condition, if I is odd, the way that I know that I is odd is this way. I have to take into account intermediate. Okay, to be a little more clear, every time that I'm going to show a message, let me write a space at the end. So they are not together. I'm not going to glue them together. Space here, space here. And after that, I go to the next line. So I'm just going to say go to the next line. So this should work and show me what I need. So let me execute it and see if we obtain the result that we want. So remember, no, the name of the command, the password that we want to hash, and the salt. So it's going to do it a lot of time. I am going to say, show me the first screen. So let's see. Oh, iteration did not change. There is a problem here. I forgot to put $I here. Okay. I want to show as a decimal value of a 4-digit the content of $I. Let's do it again. Okay, so let's verify. Here we have the first 11 line. Let's verify what we have. So iteration 0 should show me intermediate p bytes. Correct. Iteration 1 should show me p byte, s byte, p byte, intermediate. Correct. Iteration 2 should show me intermediate, s byte, p byte, p byte. It's correct. Iteration 3 should show me p byte, intermediate. Okay, so look, it's correct. Let me just verify iteration 11. It should show me p byte, s byte, p byte, intermediate. So it looks like it's okay. So I just wanted to verify that I did program it correctly. So of course, this is not the objective. The objective is not to show that, but the objective is to calculate the new value of intermediate. So remember that intermediate at the beginning is initialized with the initial value that we computed previously. So let me put that. Before the for loop, I'm going to put intermediate is equal the initial value. So we have a variable that we compute that is called init value. Let me show you. We did that last time. Here it is in this line, init value. So we already have the initial value. Okay, so this is the value of intermediate. So then instead of doing that, I'm going to compute what we need. So let me define a temporary variable, TMP, and it starts with empty. And if it is even, I have to take into account intermediate. So what I'm going to do, instead of showing it in the screen, I'm going to update temp. So temp will be the previous value of temp concatenated with intermediate, because I take into account intermediate. Now I need to take into account the p byte if it is odd. So what I'm going to do here is update temp. So I concatenate with the old value of temp and the p byte. So the string for the p byte, we call it p byte, like that. Lowercase p, uppercase b, and YTES. Okay, we can see, for example, here we can see the S byte still in this program and the P byte. No, we call it like that. So it's why I just did that. So then if it's not a multiple of 3, we want to take into account the S byte. So we are going to update temp. It will be the old value of temp concatenated with the S byte. Then, if it's not a multiple of 7, we are going to update temp. So it will be the old value of temp concatenated with the p byte. Then, if it's even, we are going to concatenate the p byte. So I update temp as the old value of temp concatenated with the p bytes. Then, if it is odd, I have to take into account intermediate. So the new value of temp will be the old value of temp concatenated with intermediate. And after that, I have to update intermediate. So in each iteration, what we do is we compute the SHA-512. So I'm going to do that. I'm going to do here the new value of intermediate will be the SHA-512 of the actual value of TMP. I compute TMP to compute the SHA-512. So I'm going to do here echo $TMP. I'm going to first convert it to binary with XXD dash reverse dash postscript. And then I'm going to pass it to SHA-512 sum to compute the SHA-512 sum. And if you remember, there is a dash that creates this command. So I want to remove the dash. For that, I use AWK. There is two columns. I just say show column number 1, not column number 2. Column number 2 is the dash. So here, I may want to show the intermediate value that I got, so I can verify that everything is working fine. Okay, let's run the program to see if it's worked now. Okay, so look, for iteration 0, we compute a SHA-512 digest. So let's verify if it's correspond to what they say here. So they say that after iteration 0, we should have this result. So it starts with 875739. So let's compare this value with what we just compute. So look at 875739. We start well. 875739. Okay, so look like we compute it well. Let's verify the result of iteration 1. We have it here. It starts with 4C, 6D, A5, 4C, 6D, A5. We go well. So those are 4,900 iterations. It's a lot. So let me go up to the end to see the last iterations, to see what value we have. It will take some time, no? Look, it's go now at iteration 500. So it will take some time to arrive to the last iteration. So here we have the last 2 iterations. So we'll be able to compare the result that we have in the slides with the result that our program is getting to see if we have not made any mistake, no? So you see it's a kind of very long. Maybe when I see that it's that long, I can say that maybe Bash was not the best programming language to use to do that. Python will have been better, or C++ will have been better. So look at this is iteration 4,998, sorry. And it starts with 54C390. So here we have iteration 4,998. And it starts with 54C390. It looks like it's okay. And we have the last iteration. Here we can see that it starts with EE21D3. And here they say EE21D3. So it seems that we did well the second part, which is the part of iteration. So we are already done 2 out of 3 parts. We are just missing the final part. So let's work on the final part. Let's see how we do the final part. So look what we will do. We will take of the result of the last iteration, which means from this result, which is the result of the last iteration, we are going to take 64 bytes, we are going to take byte 63 as the first byte, then byte 62, then byte 20, then byte 41, blah, 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 blah. And we have other steps. For now, I just want to go through these steps. So let me show you the next slides. So here they say, this is the result of the last iteration, no? Let me show you this result of the last iteration and what we have in the virtual machine so we can compare them. So the last iteration starts with EE to 1, D3. We have EE to 1, D3. Okay, to make it easy, I put color. So for example, in this line, this is a byte in black. Then we have a byte in blue, another byte in black, another byte in blue. In this line, which is the continuation of this line, we have a byte in green, then a byte in black, then a green, black. So it's a little easier to count. So in each line, we have 16 bytes. Here we have 16 bytes. So if I want byte number 63, byte number 63 will be this one. Okay, so this is byte number 0, byte number 1, 2, 3, up to byte number 15. So this will be 16, 17, 18, up to 31. This will be 32, up to 47. This will be 47, the D7. This will be 48, up to 63. So if I want byte 63, it's 40, it's 7, 5. So look at, here we have 7, 5. Then we want byte 62. Byte 62 is this one, 3, 1. So here we put 3, 1 as the second byte. Then we want byte 20. So remember, this is byte 15, the 6A. So 15, 16, 17, 18, 19, 20. 20 is this 3B. So look at it here. Okay? Then we want byte 41. So remember, this is 15. This is 31. So if we want 41, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41 is 66. So look at the next one, is 66. So I just repeat that up to the last one. So let's see, for example, the last one, let's take the last 3 one. So this one is 0. 0 is EE. So here we have EE. Then we have 21. So this is 15, 16, 17, 18, 19, 20, 21. 21 is B0. And the last one is 42. So here we have 15. Here we have 31. And we want 42. So 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42 is 66. Is this 66? And we have it here. Okay, like the last byte. Okay, the last byte. You already understood? Okay, so let's do this step. We have the last value and we want to generate this string. So it's why I wanted to work with string before we at the beginning of the class. So I need this array. This array is a random array that they decided to use. So I'm going to copy this array in my program. So let me put it at the beginning of the shell. So I'm going to call it, for example, array. And I'm going to put inside all the values. Okay, so when you define an array in Python, there is an and here, I'm going to remove it. You cannot have commas. So I need to remove all these commas. So you can go one by one, but I'm using VI because it's very powerful. And with VI, I can say remove all these commas. So look at what I'm going to say. I'm going to say in this line, replace as a substitute. Replace a comma by nothing. And I want this to be repeated on the whole line. Look at the result. You see? I didn't have to go and remove one by one the comma. So it's very powerful. Okay. I can present the result a little better, but I can just keep this array like that. Okay, so let's do it. I need to go over all the elements of the array and create a new string. So this string, I'm going to use again the variable temp. I start with an empty string. Then I'm going to do a for loop to go all over the element of the array. I know that there is 64 elements in the array. So what can I do? For example, I can do for I that starts in 0, I less than 64, I plus plus, do, done. What should I do here? I need to update temp. How I'm going to update temp? So I need the previous value of temp, and I'm going to concatenate at the end of this previous value. I'm going to concatenate something that I'm going to get from intermediate. So intermediate sub, not sub I, of course. It's sub there is an array that I call array sub I. So I might define a variable first that is called index. So I'm going to have the index to get from the array. So how do I get the index? I need elements sub I of the array. How do we get elements sub I of an array? So it's $, then we put curly brace. The array is called array I. So this will be element sub I. Now what I need is intermediate sub-index. So how do I do intermediate sub-index? So intermediate is a string. So I need to do, look, let me show you again. If this is intermediate, the last string. If I want the first byte is these 2 characters. If I want the byte 0, I should say, is these 2 characters. If I want byte 1, is these 2 characters. If I want byte 2, is these 2 characters. So this is a string. So if I want byte 2, what should I do? I multiply 2 by 2. And I say I want the string, the substring that starts in 4. 0, 1, 2, 3, 4. Let's say that I want byte 3. If I want byte 3, what should I do? 2 times 3, which will be 6. So I want to start in index 6, and I have 2 elements. Okay, 0, 1, 2, 3, 4, 5, 6. So what I should do here is what? I need to do 2 times index. How can we do 2 times index? If we use the C++ syntaxes, we can just write 2 times index. And I need 2 characters. Okay, I think we are doing well here. And I'm going to echo this string to see if I did any mistake. So it might take some time to be executed because, oh, I still have the echo here. Let me remove it. Okay, I don't want, it will make it even longer. So it will take, so the iteration is here at the beginning. We don't want to show it anymore. Let's see. Okay, now it's compute, and after some time it will show me the result, and we are going to compare the result that it will show me with the result that I am expecting, which is this one, 7.3, 3.1, 3B, 6.6. Okay, let's expect the result. Look at the time that it takes. It takes some time. That's why I say it's not a good idea to use bash to do this programming. Okay, so we have 7.5, then we have 3.1, 3B, then 6.6, then 1.5, then 5D. Okay, we start well. We can see if we want the final part. The final part here is EE B066. EE B066. Okay, we did that correctly. So we already did this part of the slides. Then after that, look at what we are going to do. We are going to convert this string in binary. We need to convert it in binary. And we need to add at the beginning, well, okay, before I say that, look at this 7 in binary is 0, 1, 1, 1. This 5 in binary is 0, 1, 0, 1. This 3 is 0, 0, 1, 1. This 1 is 0, 0, 0, 1. So, and let's see the last 4 hexadecimal. So here we have a B. Let me see if I can see this B. So 4, another 4. So here is the B. Here. 1, 2, 3. This is the B. No, this is not the B. Sorry. B0. So I need 4. Oh, this is not the end. The end is here. That's why it didn't work. So I need 6 at the end. And we can see 6. Then I need another 6. We have another 6. Then I need a 0. We have a 0. Then before the 0 we have a B. So the B is here. We have a B. Then before the B we have an E. This is an E. Okay, so we just need to convert that in binary. So, how can we convert that in binary? You have any idea? We have an hexadecimal string and we want to convert it in binary. So it's pretty straightforward normally to convert to binary. Let me create a function. You remember how we create function in bash? Or you want me to make a small review? I want to create a function that do the following. If I pass to the function, it will have only one argument. Let's call it, for example, eggs to bin. If I pass it 0, I want it to give me 0, 0, 0, 0. If I pass it 1, I want it to give me 0, 0, 1. If I pass it 9, I want that. Okay, because it's go from hexadecimal to binary. If I pass it, for example, let's say A, I want 1, 0, 1, 0. If I pass it B, I want 1, 0, 1, 1. And if I pass it F, I want 1, 1, 1, 1. So I want to create a function. So let me remind you how functions are defined. So if I want to do a function in bash that receives 2 integers and do the sum, I can do, for example, a function that is called sum. and it will echo the sum. So I can do, for example, echo. Okay, the first parameter will be $1 plus $2. I'm using here the syntax of C++ with double parentheses. Echo yeah, I know what is going on. I should go to the next line and put echo. Or I should put a semicolon. I could have put a semicolon. Let's see. $1 plus $2. Okay, let's see if I can do sum of 12 and 3. It did work. Sum of 12 and 7. It did work, no? So the way that I can do it also, I put semicolon here. Yeah, like that. Semicolon here, sum. Can I? Oh, no, I have to do that on several lines. Like I did, let me see. This one is correct. Yeah, this one. So it's just a semicolon that I need after the echo. Yeah, that's okay. So we can do functions. So let me define a small function that will do what we want to do. So let me call it, let me create a file. We will work with this file. So we are going to define eggs to bin. And x to bin will be a function that receives hexadecimal and return something in binary, the equivalent binary. So I can do a long if. I can do, for example, if $1 is equal to 0, then echo 0, 0, 0, 0. Else, if $1 is equal to 1, then echo 0, 0, 0, 1. So let me copy this. If $1 is 2, I'm going to echo 2. If $1 is 3, I'm going to echo 0, 0, 1, 1. Okay? Let me put a phi here. I'm not going to finish it. I just want to show you that we can do that. For example, then I can do echo, for example, let me call the function to see that it works. So eggs to bin of 0. So it will show 0, 0, 0, 0. Or I'm going to echo x to bin, we did 3. So let me, since I create this file, AA, let's verify that we can run this AA. So bash AA. So look, you see, it does work. Of course, I have not finished it, so I cannot, for example, say, show me echo 5. Because if I want echo 5 to work, I will have to put more information, no? So I would have to, for example, do the 4 here. Let me do the 5 also. So it's take me a long time if I do like that. So I can do it like that, but there is something that is better. So now I can do that with the 5. It will work. So look at, this is the 5. So instead of doing that as a function, let me show you. There is a tool that is called basic calculator. And you can say to basic calculator, for example, I want the output base to be base 2. I want the input base to be base 16. And if I show you A, the output is 1010. If I ask for F, so when I'm typing, because I say the input base is 16, I have to type in hexadecimal. And since I say the output base is 2, it shows me the result in base 2. Look, if I'm going to type 5, unfortunately, it's not going to show it in 4 digits. 5 is 101. So I need to make a small correction for it to be on 4 bits. So instead of doing this, let's do something better. This will take a long if. So I'm going to use basic calculator. So I'm going to say, okay, so the result is going to be, I'm going to execute something, echo the first parameter, no, echo, sorry. So we are going to say the output base is going to be 16. The input base is going to be 2. Yes, I want to send the value. This is what we did, no? Output base, input base, the value. I want to send the value on all this to BC. And here, let's just put echo $result. And it will work partially, but it will not show it on 4 digits. So for example, I can say, show me the value of A, or show me the value, for example, of 9. Let's execute it now to see that it works. So, show me the same value. X to bin, echo, the output base is 16. The output base is 2. And the input base is 16. Because I'm going to convert from base 16 to base 2. Let's do it again. Okay, so this, the first one is 0, the second one is 3, then we have 5, then we have 8, then we have 9. So the problem is that this one is over 3 digits, and this one is over 2 digits, this one is over 1 digit. I want all of them over 4 digits. What can I do? I can put 0 at the beginning. So I can do, for example, it's a string. So I can say, why the length of the string is not 4? Put a 0 at the beginning. So how can I say why the length of the string is not 4? So if you remember, to get the length of a string, I use this notation, no? You put number on the name of the string. So the string is called result. So why the length of the string is less than 4, I'm going to add at the beginning a new 0. Do done. So we are going to do result is equal the previous value of result, or a 0 at the beginning. So let's put 0. and the previous value of result. I'm going to put a prepend. I'm going to prepend a 0. Let's see now if I execute that. So look at, we have 0, we have 3, we have 5, we have 8, and we have 9. Okay, it's walk. Now that I know that it's walk, I'm going to bring it, make a copy and bring it in my program. Let me put it at the beginning. So we have the array here, and we have this one that allows me to convert. Okay, very good. I already know that this function walk, x to b. So what should I do here? I need to convert temp, that is in hexadecimal, to binary. So let me show you, where did we run that? Let me maximize it. Okay, I don't have it anymore. Okay, so I'm going to run it again. Where did I run it the last time? Was it here? This is the history of my phone. Okay, it was not here. Now I have a lot of window. Let me see the history here of my commands. Okay, this is the one that I was looking. Line 255. Okay, it is running, line 255. So it will show me the result. It will show me the result, in this case, in hexadecimal. But I want to show the result in hexadecimal and in binary. So let's create a new variable that we are going to call temp bin. It starts in empty. What should I do? I should go over all the character of temp, and for each character of temp, I'm going to call this function that I just created. So let's do that. So we are going to do a for. So I is equal 0. I want to go all the character of temp. So I can say I is less than the length of temp. So I is less than the length of temp. How do I get the length of temp? Temp is a string. So the length of temp will be $ curly brace sharp temp. So while it is smaller, what should we do? We need to update temp bin, which is going to be the binary. So I'm going to take the all value of temp bin and append at the end a call to the function that I just did. The function that I just did is called x to bin. And when I call x to bin, I have to pass one character of the string. So I have to pass just one character. And the string is called temp. And when you want a character, I need character I. So here I'm going to put $I because I need character I, and it's just one. Okay, I think I'm doing it well. And at the end, we are going to echo $temp bin to see if it is correct, the value. So we'll have both the value in hexadecimal here and the value in binary here. Let's do it to see. This will take some time before we see both results, but we will have them. Yeah, it's not the best programming language to do that, as we can see. Okay, so Here we have 7. The first hexadecimal is 7. Look at the 7. Then we have a 5. We have a 5. Look at the 5. Then we have a 3. Look at the 3. Then we have a 1. Look at the 1. Then we have a 3. Then we have a B. Oh, the B didn't work. I know why. Because we need to first put it in capital letter for it to work. So there is something that I forgot to do here. Let's put it in capital letter. Let's put this result in capital letter. So let's put temp. How do we put it in capital letter? There is a small command that is called tr for translate. So we are going to echo the variable temp, and we are going to send it to tr, where we are going to say that the letter from A to F, we want to change them for letter from A to F. So let me run that again to see if now we solve the issue, that the numbers, the digit was working, but the letter were not working. Because BC, we are using BC in hex to bin, and BC require hexadecimal in capital letters. It's why I need to put it in capital letters. So let's see. Here we have a 7, then we have a 5, then we have a 3, then we have a 1, then we have a 3, then we have a B. Bingo. So it's working. Okay? I can look at the last 4 digits. We have a 6, correct. Then we have another 6, correct. Then we have a 0, correct. Then we have a B, correct. Okay, so we did this part. Let's see what else the slides. We are getting close to the end. So we convert in binary. So if you look at the slides, they say that you need, after that, to add 4 binary 0 at the beginning. And then, look at what they are going to do. They are going to do from right to left, group of 6 bits. And for each group of 6 bits, they are going to do the base 64. So look at the base 64, use this table that is there. You see this table? It's for the base 64. So for example, if a group of 6 is a 15, I have to replace this 15 by a D. If it's a 12, I have to replace it by a capital A. If it's a 6, I have to replace it by a 4. If it's a 1, with a /. So we can obtain the final result, which is this one that we want. We want to now to go this, and this is the last step. So let's do it. So as I was telling you, one of the first steps that we need to do is to add 4 0 at the beginning of the binary. So I don't need to show that anymore. I'm showing the binary. Before I show the binary, I'm going to add the 4 0 at the beginning. So I can do temp bin is equal 0000 $ temp bin. So I added the 4 0 at the beginning. I prepend 4 0. Okay, now I need to go. This is a string. I need to go from right to left, and for every group of 6, I need to replace by the base 64. So let's do a 4 that will give us each group of 6 from right to left. So since we know that the final result have 68 bytes. Let me show you that again. At the beginning, we were saying that. Said 86 bytes, sorry. The final result of 86 bytes. Since we know that it have 86 bytes, we can do a for that will pass 86 times. And since we need to go from right to left, we might want to start in 85. While I is greater or equal than 0, I minus minus. So I go down 85, 84, up to 0. I will pass 86 times. Do, done. So I'm just going to show a group of 6 for now. So echo, to be sure I'm not doing something wrong. So if I want to show a group of 6 of 10 bin, it will be like that. The index here will be what? So the index here will be 6 times I. And I want to show a group of 6. Okay, I think it's correct. Let's run that. So for example, the first group of 6 that I want to show is this one. 1, 2, 3, 4, 5, 6. Then I want to show this group of 6 because I have to go over the binary number from right to left. So let's do it to see if it's work. Oh, it's a lot of numbers. I need to put pipe less. Otherwise, it's going to go. Let me see. Pipe less. Yes, I did pipe less. Okay, let's wait. Let's take some time to do. And I need this table. There is a table. I need it. So I will have to define the table. Let's see, still computing. I'm going to close this one. I don't need it. Okay, so is this the last one? So 1, 2, 3, 4, 5, 6, 1, 0, 0, 1, 1, 0, correct. So then we have 1, 2, 3, 4, 5, 6. Yes, correct. Then we have 1, 2, 3, 4, 5, 6. 1, 0, 1, 0, 1, 1. 1, 0, 1, 0, 1, 1. Okay, we are going well. We take them by group of 6. So then I need to convert this group of 6 to a character. And this character is according to the table. There is a table here, which is base 64. So a group of 6 will give me a decimal between 0 and 63. And according to this decimal, I need a character. So let's do it. What should I do here? Let's make a conversion because we have this in binary. Let's make a conversion to decimal. How can I make the conversion to decimal? Let me show this value. Let me call this index. Index in the array. And I want to show the index. I'm going to show it in binary, and I'm going to show it also in decimal. What can I do to show it in decimal? So I can use also the BC calculator that we saw. So I'm going to say that the output base will be 10. The input base will be 2. And so I need to echo this, sorry. Echo this. I need the index, and I need to send that to BC. So it will show it in decimal. On the side, let's do it again to see. And I need this table. So let's see the table. The table starts with a dot, then a slash, then the digit, then the capital letter, then the lowercase letter. So while it's computing that, let me define this table. Let me call it base 64. So the first one is a dot, then a slash. Then I want all the digits. So I'm not going to write 0, space 1, space 2, up to 9. It's take a long time. I want all the uppercase, which are 26 letters. And I want all the lowercase. So this is, let me show you that it works. Base 64, it will be an array. Let me open another window and see. Paste. If I do echo, show me the content of the array. It is called base 64. Show me all the elements. I forgot to put the curly brace here. Let's see. It starts with a dot, a slash, all the digits, all the capital letter, all the lowercase letter. It's okay. So let's see now here. Is this 38? So this is 32 plus 4 plus 2. Yes, it's 38. This is 1, there is no doubt. Is this 43? So this is 32 plus 8, which would be 40 plus 2 plus 1. Yes, it's 43. So the conversion is okay. So I do have the number in decimal. So now I need, since I have the number in decimal, I just need to take the base 64 of this number. So look here. Let me go here and maybe update the index with the decimal value. Here we have the decimal value in the index. And I'm just going to now define the final result. So this is called encrypted. How they call it in the, let's see how they call it. Encrypted field. The final result that we need. So I'm going to put here encrypted field start in empty. And every time that I pass, I'm going to update encrypted field. So the new value of encrypted field will be the all value of encrypted field concatenated with the, I need one element in the array that is called base 64. And this element is the element subindex. Okay. I'm done here for this 4, and I can show the result to see if it is correct. If the result is correct, we are done. Okay, let me see. Let me run that to see. Yeah, I didn't need the less this time because did I remove it? Yeah, it's just going to show the value in binary. I can remove it now. I don't need it anymore. And the encrypted value. So let's wait. Okay, look at the encrypted value. Let's see if it's correspond to what they have in the slide. It starts with so it is there, A/FVVK. So let me put it here and let's compare. So A/F, lowercase v, uppercase V, K, G, 0. And at the end, we have, let's compare the end. The end is, for example, AH, HAP/. We have it here. So it does work. So let me remove what we don't need. We don't need to show it in binary. And what we need to show now is the final result. So echo. We want to show a dollar sign. Then we want to show a 6. Then we want to show a dollar sign. Then we want to show the salt. Then we want to show a dollar sign. Then we want to show encrypted. And that's it. So let's put here the encrypted password or the hashed password. Hashed password is, and if it works, yeah, I don't need the less anymore. It's take a long time, but it will hopefully work. We can do it in Python. I'll let you do it in Python. It will be much faster in Python. So the hashed password is $6. We have the salt and we have the Eric encrypted. So look, now that we know that it works, let's verify it for other value. So for example, I have a user. Let me see how many users we have in this machine. We have a user that is called John. So I'm going to go as John dash switch user and become John. It's going to ask me the password of John. I think it's John. It's not John. Do you remember what is the password that we put for John? Okay, better. I'm going to go as the root. And I'm going to change the password of John as, for example, as Jacksonville, all in lowercase. Jacksonville. Repeat it, Jacksonville. Okay, so let's verify what is the password of John. So I'm going to check in the etc shadow. So look at this is the password of John. It's end here. So we have $6. We have the sum. So the sum is a random sum. We have $1 and we have the encrypted password, which is this. So let's see if I can find the same thing with what we developed. So I want to encrypt Jacksonville with the salt. Okay, so I need to copy the salt. It's a random salt. So what is between $1 and $? We copy it. And here I'm going to remove this one and paste the one that I just got. And we should have exactly the same password. So let's see if we can compare them, put them. So it's starting as in GCWK on end. So GCWK, as you can see, and end in 9GT7SYG0. 9GT7SYG0. So you see, we did a function, a program that will compute. So look, there are many ways to represent Jacksonville. So for example, if I change again the password of John, I put again Jacksonville. 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 So Linux will update this file, but with another salt. So look at. You see, the salt here is different from the previous one. So the encrypted password, this is Jacksonville encrypted with this salt. So the same password Jacksonville is encrypted differently, is hashed differently. So I can ask what we have developed to compute the hashed version of Jacksonville with this salt. So do you understand what is the salt? What is the objective of the salt? So let's say that if Jacksonville were always encrypted the same way, what will be the problem of we always encrypt Jacksonville the same way? Here we don't encrypt Jacksonville the same way, as we have seen. We have many, many different ways to encrypt Jacksonville. So look at my result. So here the dollar, it starts with ML, I think it's a 0 or 9, ZGA. Let's see here, ML 0 or 9, 0 sorry, 9 ZGA. And at the end, let's see the last character, we have NWBGMJ0, NWBGMJ0. So this is another way to encrypt Jacksonville. So why it's good to have different ways to encrypt Jacksonville? Why do you think it's good? And Jacksonville is not always encrypted the same way. So let's say that I change the password now. There is a user that is called, let me create a user better. So add user, let's put Sally. Password, Jacksonville also. Jacksonville. Jacksonville. Full name, Sally Thompson, for example. It's correct, yes. So let's see the way that the password of John and the password of Sally were coded. I want the line that have John and Sally. John or Sally. Extended grape. I don't remember. Okay, let's do it in two time. First John, then Sally. I create a user that is called, let's see. Oh, Shally. I create Shally. Okay, so Shally. Let's do it again. Shally and John. Okay, so look, the hash, the salt, sorry, was different. So if Sally and John have access to this file, they will not know that they have chosen the same password, which is Jacksonville, because they will see a different string. This is one of the benefits of encoding Jacksonville or a password in many different ways. That if you show me the string 2 times, I cannot say, oh, it's the same string, because the hashed version will be different. So it's why we use that. We use a salt, and this salt is random. So when the person changed the password, the operating system generates a random salt, and with the random salt, compute the encrypted password. And we will have this as the password of John that correspond to Jacksonville using the SHA-512 algorithm. Okay, so in Linux, they have many different algorithms to encrypt a password. So I realized that they are not using the SHA-512 with the last release of Debian. So with Debian 11, they are using another algorithm. But before, they were using MD5. There is another hash algorithm that is called MD5. And unfortunately, MD5, they find some weaknesses with MD5. And they are stopping using MD5 because of the weaknesses that they find in MD5. So it's why they move from MD5 to SHA-512. And you can recognize that the password is in MD5 because it starts with $5, saying that it was the 5th algorithm. And there are other algorithms. So the magic number, which is the first part of the hashed number of the hashed password, will tell you which algorithm was used. And as I told you, there are many, many different algorithms. Okay. So for today, it's all. And it was an explanation of how the passwords are encrypted in the shadow file. So you can look at this file, the etc shadow. So normally it have a user, colon is the separator. You have the encrypted password, and you have other field here to define, for example, you can force the user. Let's say you say every month I want the user to change its password. So those fields that are defined here will allow you to do that. Force the user to change its password every month. So they keep information about the password, about the time to live of the password. And I do have a lab on this. If you are interested, I can send you the lab where you will know all those fields that are here. Okay, so for example, if you look, for example, this user mail don't have password. So it's not a user that will be able to log. And if we continue, we have the user Eric. So that's Internet 2 encrypted. We have the user John. That's Jacksonville encrypted. And we have the user Shally. That's Jacksonville also encrypted with SHA-512. Okay, that is it for today. Thank you.